Hello everyone, welcome to episode 56 of The Followers. Today we're joined by special guest Dr. Gabrielle Fundaro, who claims herself not to be the gut health expert, but I think is as close to what we can get as an expert in gut health. We looked at all the various things that contribute to gut health and even started off by, first of all, defining what are some of the symptoms of gut ill health, because what is health, what is fitness can be a bit kind of fluffy and up there in the air and difficult to define. But when we start looking at some of the negatives, and when we can pinpoint those, we can see much clearer what we may need to go and fix. Cleared up an awful lot of misconceptions around various things that contribute to gut health or realistically don't contribute, and what some of the things we can do to promote or manage or optimize optimal gut health.
For me, the big highlight from actually a lot of the information that Dr. Fundaro does put out, as well as what was discussed on the podcast, was just what we know, how small of a kind of a canister of information that is when it comes to the gut, versus kind of what we tend to see or hear being spoken about in, and I use invert commas here, expert analysis. So it's I think there's a lot to be taken from this episode, from just understanding where the science is at, where what we know is at, and more importantly, where what we don't know is kind of at, and just taking, I suppose, that kind of, I know you mentioned expert there for Gabrielle, but just keeping an eye on information that is coming your way when it comes to gut health, and how that is being portrayed at the moment. So yeah, those some huge insights and a lot of learning here for pretty much everyone.
Also bear in mind, my microphone got a little bit cranky for the last 10 minutes, so apologies for that. You should make out what I'm asking, but bear in mind, Gabrielle does the majority of the talk, and I try to stay as silent as possible, so you still get all of her really good information.
All right. I hope you enjoy today's episode.
Gabrielle, just looking at some research before we started all this, it's like you've background in a few different physical activities: trail running, competing in figure, powerlifting, everything that way. Something I've noticed from all those, they all have very, I think the word is, significant relationships with food and diet. Is that what brought you down the route of studying nutrition and that end of physiology, or was it something you'd always kind of look towards, and maybe that's why you gravitated towards those activities?
Actually, I didn't start engaging in real physical activity until college for the most part. I did a little bit of like running and lifting in high school, in the phys ed classes that you take. But I started lifting in college because I wanted to become stronger for rock climbing. So my undergrad institution had an indoor rock wall, and I thought it was super fun. And I made good friends with a guy who was just a complete gym rat. And so I started lifting, and it was just like, I had no idea what I was doing because I was actually a music therapy major. But over the course of my first semester, I was like, I'm not super stoked on art and music history, and I'm really super stoked on my biology classes and lifting. And so I switched majors and totally shifted gears to exercise science, and really fell in love with the sliding filament theory and skeletal muscle metabolism and tutoring for anatomy and phys. And that really led me down the path of pursuing a PhD to actually study skeletal muscle hypertrophy. And getting into gut health was actually sort of an accident. And the sports, I guess I just picked them based on interest, accessibility, curiosity, and my most recent addition has been ice hockey. So I'm starting that on Sunday.
Really? In Arizona?
Yeah.
I didn't think you have much access to ice down there.
Yeah, we've got to, they have to ship it in, it's only indoors.
So that kind of, that's quite, I wasn't expecting that change now from music therapy into the more biology. Do you think that's because you were getting into rock climbing and what supported that at the same time as learning a bit about it physically, like, oh, this has really piqued my interest, I want to go further down this route?
Mm-hmm. The intermediate was actually recreational therapy because I still wanted to have a helping role, a therapeutic role. And recreational therapy was one way to do that while engaging in physical activity and spending time in the outdoors. And I was a little bit turned off by that because there was a required leave no trace training. So you'd have to go out into the woods for like 2 weeks or something like that. And at the time, I wasn't as big into hiking and camping as I am now. So I thought, oh, I don't know about that so much. And, I really enjoyed lifting. And I understood enough to know like that was an effective way of increasing muscle mass and strength. And I thought when I switched to exercise science, after recreational therapy, that I was going to kind of go the traditional route of that major, which was into the commercial side of things. So, owning and running a gym and personal training. And then what turned me off of that was the liability side of things, and actually, marketing and learning how to run a business, which ironically I do now, but but outside of, an enclosure, outside of an enclosed space. And so I've kind of gotten back to my roots now of having a helping role. I'm working one-on-one with folks, and I'm collaborating with them to help them find balance in their relationship with food and body image, and live a more abundant lifestyle. And so it's sort of, I think it has been the synergy of like all of my interests and previous paths, it's come together into my current career, which is not what I expected either.
Yeah, we'll dig into that more of that towards the end. Just briefly before we dig into, I suppose, the meat and potatoes of gut health, where did you do your education, your undergrad, your PhD? What colleges were they at?
So I was at Radford University for undergrad, and that's a pretty small. Well, it's larger now, but when I was there, I think there were only like 6,000 students. Small liberal arts college in southwestern Virginia, and then I went on to Virginia Tech for my PhD. People are probably more familiar with that, and I was able to skip the master's side of things. Some programs here in the States let you just go straight from bachelor's to PhD. Just that your PhD, takes a little bit longer. So I did a 5-year stint and a teaching fellowship within that as well. So yeah, I spent quite a long time in southwestern Virginia, and it's still one of my favorite places.
So the real reason we got you on was to talk about gut health, because I know you'd be quick to say yourself you're not the expert in, or the gut health expert, but you are, haven't done an awful lot of studies around it, probably as close to an expert in gut health. And from looking at different things, and even just areas in general, when we try and define stuff, realize that this definition doesn't really help people that much. So I think we might start coming at it from the other angle, and first of all outline what are some of the symptoms of gut ill health, because people listening might pique their interest, like, oh, that's something I've noticed recently or over the past while. So we'll start with that, and then we can start maybe digging in a bit deeper to see what causes them, how we can help it all like that.
Yeah, absolutely. Yeah, it's a great point. Gut health is often used as sort of a marketing term. And it's really important for people to be able to identify the real red flags of a potential gastrointestinal disease. Because sometimes those can be overlooked, and people might be, distracted in their pursuit of a supplement or some, maybe unsubstantiated gut reset sort of protocol. And it's important to also keep in mind that the gut microbiome, so the collection of microorganisms and genetic material that reside in our GI tract, the health of that ecosystem is related to gastrointestinal health, but we don't have a causal relationship between those two. So when we're talking about, the diversity and the resilience of that community, that's actually really a separate thing from the presence or absence of a gastrointestinal disease of the host, of the human. So if a person were to be experiencing extreme pain that's relieved when they have a bowel movement, a lot of cramps, chronic diarrhea or constipation, so it's happening most days of the week that you're feeling very constipated, or that you're having multiple bouts of diarrhea throughout the day, those are some red flags that a person would need to visit a gastroenterologist. Some more potentially serious red flags would be the, seeing blood in the stool, so either bright red blood or very dark, or if they're waking up in the middle of the night to have bowel movements, or if they're having a difficult time passing bowel movements and it's super, super skinny when it comes out. So those are signs that it's a good idea to go visit a gastroenterologist and get screened, because there are interventions for which, food can be helpful. And then there are real disease states that require a diagnosis and pharmaceutical intervention. And I think it's really tragic when people don't know that those are really serious and don't seek help. And on the other side, it can be equally tragic when a person is experiencing something that's quite normal, like a little bit of bloating or gas associated with, eating highly fermentable carbohydrates. And the industry tells them that this is a sign of quote unquote bad gut health, and they need 1,000 supplements and a very restrictive protocol, and that it's the cause of all of these other ailments. And they're really creating a problem where there isn't one.
Yeah, that was kind of a follow up I had, that it's the kind of the chronic and acute, or the consistent and the once off. Is over what kind of consistent period does that become a symptom of some form of underlying ill health? And even tied into that, if we're doing things that lead to an acute ill health response or something like that, can a few of those together lead to long-term damage? Or I don't know, is damage even the real word there? I'm careful on what I'm saying.
Right. I know. So damage is one of those kind of like, could be like a buzzword type of thing. So there are some things that we might do that would to cause or be associated with, acute GI distress. So pretty obviously something like a foodborne illness. Now, what's interesting with the foodborne illness is that we would have the acute effect of, some amount of days of being really ill, and that actually could cause post-infectious IBS. So irritable bowel syndrome that comes on spontaneously after an infection. It can last for quite a long time. It can last for years. So that's something that have both sort of acute and long-term effects. Or if we engage in a really intense bout of exercise, that can also cause GI distress. There's exercise-induced gastrointestinal syndrome. So people experience a lot of cramping, pain, diarrhea. Kind of the cute name for that is runner's trots. That doesn't necessarily mean that there's been damage to the gastrointestinal tract, but that we've caused some sort of extreme perturbation to the system, and we have some kind of an abnormal nervous system response in the gut. In terms of the signs of sort of a chronic illness, those are like the kind of red flags I had mentioned before. The kind of normal range of bowel movements would be 3 times a week to 3 times a day, and they should be on the Bristol stool scale about a 3 or a 4, so well formed, pretty solid. That come out and you feel like you're done. You've completely evacuated, had the bowel movement, and then you go on about your day. So if you're outside of that range and or you're experiencing all of these other things that are going on, then again, that's like go to the gastroenterologist, get screened. I know that people feel understandably frustrated, that they have to go and get a colonoscopy and all these tests, and it seems like they're put through the ringer, and sometimes there's nothing going on, and they might receive a diagnosis of irritable bowel syndrome. But I'm just on the side of, we are seeing colorectal cancer rates in younger and younger individuals now, and that's a sign that, it's important to get checked out, even if you are not, 50 years old yet, and, you feel fine otherwise. You don't necessarily have to, settle for uncomfortable bowel habits.
And while it can be difficult to define what gut health is, just thinking of some of my own research, like I look at mental well-being, so difficult to define, but there is a way to measure through various scales. Is it similar with gut health? Difficult to define, but we can measure it, or is that quite probing, quite invasive, whatever, accurately?
Right. So to some extent, it's probably easier to identify an illness than it is to identify health. I mean, it's the same thing when we're talking about health in general, because it's multidimensional. It's not just physical health, and it exists on a spectrum. And health to one person will look different from health to another person. And really the same can be said for the gut microbiome. So the kind of working definition that I've come up with for gut health looks at the diversity of the microbiome, and that kind of has some subcategories. The presence or absence of disease, and then the experience of digestion. So I call these the 3 Ds. So it's the diversity, disease, and digestion. That's usually what people are referring to when they think about gut health. So we can obviously diagnose diseases. We have specific diagnostic criteria for those. People can have subjective ratings of digestion. They can subjectively rate stool quality, gas and bloating, frequency and bowel movements, and there is some overlap between that and the diagnostic criteria. And when it comes to the gut microbiome, we're generally looking at, within one person, the richness and the evenness of species that are present. So we don't have a specific number, we don't have a specific reference range for this is the number of species we should see and this is the relative abundance that we should see, and can say that's healthy, because healthy individuals are quite unique from person to person, but also very unique as a group looking by regional sites. So in the UK versus the US versus South Africa and Korea, healthy controls would cluster by region. But what we are getting a better sense of are things like the core microbiota. So these are microbes that we would expect to see in a human. And if they're absent, if they're entirely absent, that's sort of odd. And we can also sometimes compare that core set of microbes between healthy individuals and individuals with a disease. And sometimes we can see that there's a significant difference and it's replicable. So individuals with IBS tend to have, fewer beneficial microbes, whereas healthy people tend to have, what we would kind of expect to see. But we're really looking at also relative abundance. So the number of microbes there. And then also if we think about it in terms of a pie chart, we are going to have 60% of one, 40% of another, 30% of another group. And, we want those to add up to 100%. Now, when we're thinking about applying that pie chart to the number of microbes, we have kind of a bigger pie chart or a smaller pie chart. But we don't have, the exact right size of pie chart that every person should have. So that's why it's very difficult to really objectively measure gut health, because we have that inter-individual variability. And then we also have a secondary measure of functionality. So we can look at who's there, which microbes are present, and then we can also look at the genes present and determine the potential functionality of the microbiome. And sometimes individuals may have a very similar group of microbes present, so the taxonomic diversity would be very similar, but one individual may have reduced functionality. And we could consider that to be one form of dysbiosis, which is a word that has a bad rep, but it just means kind of like different from the controls, different from what we would expect to see. Now, here's the kicker. Even in an individual with a disease who has a different microbiome from a healthy control, that doesn't necessarily mean that that's an unhealthy microbiome. It could be their healthiest potential microbiome. It's that the ecosystem has adapted to the challenges of the diseased environment and is running as well as it possibly can. So when it comes to terms like gut health, it can be used in so many ways, and that's why it's really primed for marketing.
I just have 3 kind of brief follow-ups to that. The first one, the gut microbiome in general is largely the function of that to process the foods that we eat so we can extract whatever nutrients we need in the GI tract, or is that a little simplistic?
It assists with that. It has a few different key functions. One would be immune defense. So the microbes are interacting with one another in a way that ideally suppresses pathogen activity and also can fend off pathogens that we might ingest. It also interacts with our immune system as we develop. It helps to keep the immune system informed of sort of who's pathogenic versus who's beneficial. And it plays a really important role potentially in also neurological development as we're aging. So it plays a bunch of different roles in that realm. When it comes to nutrient assimilation, really it's our own digestive tract. It's mostly our small intestine. That's the site of the digestion and absorption of nutrients that are accessible to us. But what's cool with the microbiome is that they have so many more genes than we do. So we're outsourcing some metabolic processes to them. And for the most part, what they're doing is taking carbohydrates that are indigestible to us and converting some portion of them to short chain fatty acids, which we can actually absorb. So this process is called energy harvesting. So they can extract a little bit of the energy that's unavailable to us and make it available to us. And the current estimates for this range are anywhere from 0 calories a day, if you don't have a very adept microbiome, up to about 200 calories per day. So it really could make a fairly sizable contribution to our absorbable energy.
And when we say we're looking at there, like, scales for measuring microbiome, but like physically, what tools do we actually use to measure it? Is it stool samples or is it more invasive? Or
For the most part, it is stool samples. Those are the easiest to collect. But there have been studies that have used actual samples from within the GI tract. So they can actually, yeah. So they do a scope. So they can do a duodenal culture. So that's the first section of the small intestine. Because it's much more acidic, there's actually lower diversity. It's really predominated by like lactobacilli because they're pretty happy in an acidic environment. And the overall number of microbes is fairly low in the small intestine. But as we move towards the large intestine, that's where we really see an increase in the abundance and diversity of microbes. So when we take a fecal sample, it's sort of a surrogate of the gut microbiome, but it actually is significantly different from what we would see in the small intestine and even within the microenvironments of the large intestine. So within the large intestine, we have the center, we call it the lumen, and that's kind of where the foodstuffs are flowing through. And then we also have 2 layers of mucus that sit on top of the intestinal cells. And the top layer of mucus is inhabited by microbes. And so when we're taking a fecal sample, we are going to see an overrepresentation of the luminal microbes rather than the that's a tongue tire. The mucosal microbes. So we have to keep that in mind when we're interpreting research, because it's sort of it's a sample of one specific population, but we actually have multiple populations to potentially sample within the GI tract. And it's very rare, because it is really invasive, to go in and try to get, a mucosal sample or a duodenal culture. And the way that we're actually identifying the microbes, we can look at a specific gene and a specific region of that gene. So we can use what's called 16S RNA methods, and that allows us to look at just bacteria. So there are actually other microbes in the GI tract, but bacteria predominate. And then we can use also what's called whole genome shotgun sequencing, or metagenomic shotgun sequencing. So that's when we're taking a look at all of the genetic material in the GI tract, and then we can observe non-bacterial microbes, so things like archaea and fungi and protists and things like that. So we can get a better sense of who's there, and we can also get a better sense of the functionality. So we're actually looking at like pathways, metabolic pathways that are present in the microbiome.
I'm just going to assume as well that with some of the stool samples, would exposure to oxygen there compromise some of what can be measured accurately?
Oh, absolutely. Yeah, actually, that's one of the big limitations in the literature, and part of the reason that it can be so hard to replicate studies, because sample preparation, the region of the 16S gene that people are using to identify the microbes, the depth of sequencing, they can use whole genome, they can use shallow shotgun sequencing. All of these things influence our ability to accurately predict the members of that population. So you can kind of think of it like if you have a big bowl of, or a big pot of alphabet soup. It's got a bunch of different letters and it's got a bunch of different vegetables in it. You can just skim the top of the soup versus dip the ladle all the way into the bottom of the soup, and you're going to get 2 very different representative samples of the whole population. So yeah, think things like exposure to oxygen, cold storage, the amount of time that it's spent at room temperature, all of those things can influence the functionality of the microbes in that sample and which are viable. Now, some methods, if we're using just DNA, that will actually tell us about all the microbes that are present, but it won't tell us who's viable or not. So that can be another limitation.
And just the last follow up to some of the stuff on the microbiome, you mentioned there about regional differences. Is that down to different diets in different parts of the world, or is it more through like genetic variants developing over time? Because like the world is getting a good bit smaller now in terms of diets, and there's a lot more mix in that way. And are we starting to see a little bit more of similarities in different parts of the world there?
Yeah, so we can actually see, and this is something that's mostly been done in rodents, which is really interesting, but they'll observe changes to the microbiome from one generation to the next on rodents who are fed very refined diets. And they see a generational loss of diversity over time. And so it's one theory behind why we might see a difference in westernized countries versus less developed countries, or if we're looking at just populations like agrarian societies versus industrialized. But when we look at sort of the explanations of interindividual variability, we can, and when we look at dietary intervention studies, there are some clues there that diet plays a role in influencing the microbiome, but there are other factors that probably have a greater influence. So the regional specificity is really kind of a collection of many different factors. And even if you put a person from the UK or Sweden and a person from the US on the same diet, they'll still cluster by region. The diet will not overcome those regional differences. So probably, that collection of regional specificity, and then things like age, that also plays a fairly significant role. Genetics tend to explain about maybe 10% of interindividual variability. And though we can't really separate diet and physical activity, diet and physical activity together might explain 20 to 30% of interindividual variability. And then the rest is explained by us being human. We have quite a lot in common, but the differences really are like region, which is, a collection of things, age, and gender.
Yeah, so we're going to start looking now at kind of the various things that do impact gut health, and we'll dig into them. Most people are generally asked around the specific foods they eat and how that impacts it. But the first one I really want to look at is actually lifestyle factors, because I think they can have a huge impact on it, such as stress, sleep, lack of sleep, whatever like that, and how they might start to impact gut health. Can you just give us like a brief overview of how they may interact with each other?
Yeah, that one's difficult to parse out in humans. So we can replicate stress in rodent models by housing mice with a very dominant or aggressive partner. So you have like one submissive mouse and one aggressive mouse, and you kind of let the aggressive one beat up on the submissive one, and then you can, take fecal samples and measure the microbiome in that way.
You don't get ethics for that in human samples.
I know, yeah, you can't put two people in a house and then like have them hash it out. I guess kind of though, like on Big Brother, or Real World, or The Bachelor. So yeah, we need to get their fecal samples. But yeah, it's those studies would be really difficult because you'd have to control for so many factors. Like most of the time when people are really stressed or they are lacking sleep, they're also probably not able to make the most nutrient dense food choices. So they might be opting for more like convenience foods and whatnot, not getting as much fiber. And what we have seen thus far in terms of, effects of like circadian rhythm disruption in humans, we just don't have very much data. Again, it comes down to mostly rodent models. And from there, we have some mechanistic data that give us some clues that there could potentially be disruption because the microbiome itself exhibits diurnal variations. So as you are fasting over the course of the night, there's going to be some die-off of microbes that have higher energy demands and higher turnover, and an elevation in those that, like a relative elevation in those that can withstand that long-term fasting state. Then the next morning you wake up, you start to eat your breakfast and things like that. You're now providing some prebiotics and some micro-accessible carbohydrates to the large intestine, and now you're going to see a slight increase in those that are that need that energy. So it's one thing that could perhaps explain some of the influence of things like chrononutrition on metabolic health, because there is an association between the microbiome and skeletal muscle metabolism and metabolic flexibility and things like that.
Is it possibly along the lines of, like, your continuum of rest and digest and fight or flight, that if you're slightly more in that higher stress state, you just don't have as much, I suppose, energy availability for digesting food? So if you're not digesting as much food as well as possible, because there's that slightly excess cortisol there over a longer period of time, and that's possibly impacting it there as well for people who live those higher stress lifestyles and everything.
Right. Yeah. I think that there's mechanistic explanation for that. I think what gets there are still unanswered questions. So, when people think about like the postprandial sleepiness, right? Like after a big meal, you get sleepy. A lot of times people think that that's due to increased parasympathetic nervous system tone. And while we do require increased parasympathetic nervous system activity to digest foods and to facilitate things like gastric emptying and gastric motility, we haven't found an actual causative relationship between like parasympathetic nervous system tone and sleepiness. We don't know why people get the itis after they eat a big meal. So the same really could be said for increased sympathetic nervous system tone. Now, if a person is engaging in really intense physical activity, like 85% VO2 max and above, they will see reduced blood flow to the intestines, delayed gastric emptying, and therefore delayed nutrient digestion and absorption. Not to say that it's completely turned off, and we're completely incapable of digesting those nutrients, but just that things are slowed down because the blood is being shunted toward working muscles.
Yeah, it's actually, if anyone wants to know more about that, it's really well explained in Robert Sapolsky's Why Zebras Don't Get Ulcers. Gives a great explanation there of the zebra trying to run away from the lion on the Serengeti. Well, I'm not going to be digesting any food while I'm running away from him. Yep. Next thing we kind of want to look at more and dig into a few aspects of diet and nutrition. So some and various claims around it, different foods we're told to avoid or eat more of. And the first we look at kind of our meat, kind of red meat, dairy and gluten, and how they may impact gut health or aspects of the microbiome.
Mm-hmm. Ironically, fermented dairy is right now considered the only probiotic food. So that means so when we give something the definition of a probiotic, that means that when it is ingested by the host, it confers a specific benefit, and it also must contain live microorganisms. So fermented dairy, things like kefir or yogurt, that would be considered a probiotic food. And the other ferments that people often label as probiotic foods are actually not. Not that they don't contain live microorganisms, but they may not contain them in adequate amounts to confer a benefit, or we simply haven't done the study yet, or the studies to show and then replicate that these specific foods actually confer a health benefit to the host. So the ingestion of dairy could certainly cause GI distress if a person is lactose intolerant, so they can't break down the lactose sugar in dairy. But there is no evidence that it actually causes damage to the gut or to the gut microbiome. And on the contrary, if you're not digesting that lactose, then the microbes can actually use that as an energy source. So even if you don't feel great, they're like, thanks, this is a great energy source for us. So like your lactobacilli, they're going to be totally fine. If you drink some milk and you can't digest it, then that, you could almost consider it that's a microbe accessible carbohydrate.
And that's something I was wondering, that while doing that in a once-off acutely makes you feel like you've got health, but doing that over a long period of time, can it lead to long-term damage? But you're saying there it isn't. It's just a repeating of the original distress or uncomfortability.
Mm-hmm. Yeah. They actually have been, there have been low FODMAP studies that have examined inflammatory markers in individuals who are eating low FODMAP or not, and they haven't seen elevations in inflammatory markers when eating FODMAPs or those fermentable carbohydrates. So again, very uncomfortable, but that doesn't necessarily mean that it's causing physical damage to the GI tract. When it comes to that kind of segues into gluten, actually. So, one of the theories behind non celiac gluten sensitivity is that people are not reacting to gluten, which is the protein portion of the wheat, but they're actually reacting to fructans, which is the FODMAP in wheat. So, fructans are these long polymers that resist digestion by our digestive enzymes and instead are broken down. They're fermented by the gut microbes, and then that results in the production of gas. And so they can feel sort of gassy and bloated and uncomfortable, and assume that it's from gluten, and it's not the case in that scenario. So that's part of the reason why non-celiac gluten sensitivity is still sort of a contentious and topic up for debate. And the other aspect is looking at antibody responses. So sometimes individuals may have an IgA response. So IgA is a specific antibody found in the GI tract, and it does indicate an immune response. It's one way that we can test for actual celiac disease. And although we might be able to observe that in certain populations, that doesn't necessarily mean then that population is mounting an abnormal immune response or that it's causing damage to the GI tract. But that's sort of what gets extrapolated when we look at the reactions to like lectins or to gluten, and say, oh, there's a little bit of an elevated IgA in these populations. Maybe that means something, but maybe not. So, it's kind of the being, putting the cart before the horse if we're just assuming like, oh, that means that NCGS is real.
It shows as well that research and stuff like this can be quite difficult, because when there are so many different factors that can impact it, to control for all of the other confounding variables, to actually measure one makes it really difficult, expensive, invasive, everything like that.
Exactly. Yeah. And it matters too that, looking at things in context. So, like with red meat, part of the reason that, it's recommended to limit that, or the initial concern was associated in part to levels of TMAO, which is a potential marker for cardiovascular disease. Well, people who eat a lot of fish also have elevated levels of TMAO, but they don't have an increased risk of cardiovascular disease. So, whether that's an effective potential marker of cardiovascular disease really probably depends on like the whole context of the person's diet, and whether red meat is problematic in isolation, not really in prudent amounts against the backdrop of a diet that, includes microbe accessible carbohydrates and prebiotics and things like that.
And next in, and this is a huge bracket category, everything but processed foods, because ultimately every food we eat is in some form processed. It just goes through various different types of processes. Are there some that harshly get bad press towards impact on gut health, and are there others then that actually do negatively impact gut health in the long term?
Oh my gosh, yeah, refined carbohydrates and sugar. People make all sorts of unsubstantiated claims about this causing, candida overgrowth, and that you have to do a sugar detox to detox candida. And candida refers to a group of normal inhabitants in the gut. So it's a type of yeast that we would expect to see in the GI tract that actually plays an important role in communicating with our immune system. We wouldn't want to completely eradicate all of candida in our GI tract. And in RCTs that try to either increase candida levels or reduce them by way of carbohydrate manipulation in the diet, have shown that there's actually no relationship between dietary sugar intake and candida levels in the gut. And that what we probably are seeing, because we have candida in our mouths, and we can actually have an overgrowth of oral candida because it's a very different environment than what we see in the gut, and we are ingesting those microbes, that potentially, sugar in the mouth could lead to elevations in numbers of candida there, and then we swallow those and see very slight elevations, but not to the point of this is an abnormal level. And and it's very difficult too to determine whether it's something that we've ingested or has actually like grown in the gut from a fecal sample. So again, it's one of those areas that maybe has It makes sense logically. Okay, they're thinking like these feed on sugar. It's something that we use to, make alcohol. And so if we eat too much sugar, then it's going to grow, out of control. But that doesn't actually play out in the literature.
And are there some additives, etc., like that we have evidence around negatively impacting?
Not yet. And I think a lot of people probably think about artificial sweeteners. And
That's
if you
exactly where I
want,
was going next.
yeah. So if you want to make artificial sweeteners look really scary, you can do like a cell culture model. So you take some microbes representative of the human GI tract, and you put them in even in an artificial stomach or something, and then you add the artificial sweeteners at some super physiological dose, and it's like, oh my gosh, this really suppressed the growth of certain microbes. Or you can do the same thing in a rodent model. And you can even kind of make it look scary in a human model if you do it without a placebo control. Or you use really small n sizes, or you do what we call pseudo replication, where we take the fecal sample from one person, one participant, and put it into 5 mice and call that an n of 5. I would argue that is an n of 1 because that fecal sample came from one person. But this is actually pretty common in the field, to do this. And while it's helpful to replicate and confirm, like, oh yes, this wasn't a fluke, I would say it's probably not the most accurate to then analyze that as though those are 5 separate samples. And so that's kind of what we've seen in human microbiome research on the effects of artificial sweeteners, that when we do it with an RCT that's placebo controlled, we don't see an effect. But if we do the pseudo replication, or we don't have a control group, then we do see an effect. But of course, we can't confirm that effect without a control group that didn't receive the artificial sweeteners.
We have to be careful as well when we say about artificial sweeteners, and that they don't all have the same chemical makeup, that one particular sweetener could negatively impact something and one could have no impact whatsoever, but people may lump them all in together. Like I'm going to say, I'm not ever certain what particular artificial sweeteners and what, but aspartame tends to be the most popularly used, but there are others. And if that had a negative impact, it doesn't mean any of the others would have that same impact, and most likely don't, because they're made up differently. They just taste similar.
Right, exactly. And people also, I think, are they might think that like sugar alcohols and artificial sweeteners are the same thing, and they're not. Sugar alcohols are highly fermentable. So when people are eating a lot of sugar alcohols and feeling gassy and bloated and having diarrhea and thinking, oh, this is because it's an artificial sweetener. Actually, that's not an artificial sweetener. It just happens to be something that is highly fermentable, and you probably would feel better if you ate a little bit less than that. Whereas something like aspartame has been shown to have zero effect on the microbiome. They just don't interact with it in a meaningful way, or if they do, it's just a dipeptide. So it's 2 amino acids stuck together. So it's how is that going to be different from any other dipeptide that would be present in the gut?
Some artificial sweeteners can lead to stomach upset in the acute sense. Is the story of the sugar-free Haribo bears in the exam? that's so fun. What ones are like that? But again, similar to the dairy, they don't lead, like overconsumption over the prolonged period doesn't lead to gut ill health in the longer term.
Right. So they've looked at aspartame, sucralose, saccharin, ACE-K. So these are the artificial sweeteners. Those are the non-nutritive, man-made artificial sweeteners. Then we have the sugar alcohols. So mannitol, sorbitol, xylitol, things that end in -ol, and erythritol. Now, erythritol is not highly fermentable, but it is osmotically active. So that means that it pulls water. So these sugar alcohols are either attracting water into the intestine, so they're going to have a laxative effect, and or they are fermentable, and so that's going to lead to the gas production. So again, not causing damage, but certainly having a laxative effect. And you actually see this warning label on sugar-free foods. Excessive consumption may have a laxative effect. Like go and look for a sugar-free chocolate, and it says that on there. It's the same thing with the sugar-free gummy bears. It's sugar alcohols, and you eat a whole lot of them, and yeah, it's basically a colonoscopy prep, but it tastes better.
Some of the sugar-free ice creams that can really have like the double negative effect on some people. They're like, oh, I thought this was so healthy, and I feel awful now.
Oh, yeah. And they usually also have chicory root or inulin, which is another FODMAP that is really rapidly fermented. So it serves the purpose of both increasing the fiber content and also creating specific mouthfeel. But that is, even if you don't have IBS, like for most folks, that's going to cause some gas and bloating and GI distress.
And something I really wanted to look at was kind of not specific to a nutrient, but the long-term effects of a diet based largely around sport and athletic performance. Now, you've kind of two different avenues you can go here. So you have people who are looking to maintain a weight, whether it be for boxing, powerlifting, weightlifting, so you have to stay under. So there is prolonged periods of calorie restriction. And then the opposite side of that, you have endurance athletes who have huge calorie needs. Like I'm thinking of, I've heard interviews with Inigo San Milan, coach of the recent Tour de France champion, and he said he gets cyclists 80 to 100 grams of carbohydrate an hour while they're
Yeah.
competing. So that's 500 grams of carbohydrate while on a bike,
Mm-hmm.
largely sugary. Is that having a long-term impact? And then the same for the long-term calorie restriction.
So potentially, but in different ways. So they're actually, when we're looking at the influence of physical activity on the microbiome, the vast majority of the literature is looking at endurance athletes, both recreational and elite. And what we've seen in endurance athletes, so looking at marathon runners, cyclists, swimmers, and then in some team sports athletes, there's a bit on rugby players, that we generally see an increase in microbial diversity compared to less active populations. And that microbial diversity and cardiovascular fitness are positively correlated. So people who tend to be very physically active, and very fit tend to have a greater level of diversity compared to like sedentary counterparts. And there are a couple of caveats to that. So there was really just one, but it was a really interesting study done in bodybuilders. And they found that the bodybuilders who ate a fiber deficient diet didn't see the increased level of diversity that we would expect to see. They were the same. Their level of diversity was not different from sedentary controls, whereas the bodybuilders who did eat adequate fiber did see increased diversity. So that kind of points to the picture that physical activity could be playing a role, and we do have some interesting data from elite marathon runners to show that at least one species of microbe can convert lactate to propionate. So they take lactate, the waste product of intense exercise, and convert it to a short chain fatty acid, potentially increasing the energy availability to the host. So that's super cool. So there could be some exercise specific adaptations, but the issue is that only of all of these studies, only four have controlled for diet. And only two of those show that physical activity influenced the microbiome independently of diet. So the diet and physical activity really go hand in hand. And these people who are eating, really high carbohydrate diets, whether it's partially refined or not, they're probably taking in plenty of fiber, and that can be beneficial. Now, those refined carbohydrates, for the most part, are being taken up by the host. So they're digested and absorbed rapidly in the small intestine. And again, we've got some microbes there that might be able to use what we aren't taking up quickly enough, but that's not really going to reach the large intestine, which is where most of our microbiome is housed. So if we were to only eat refined carbohydrates, like all 500 of those were refined and that's all we had for the day, potentially that could be problematic. Potentially we could see a reduction in the diversity, especially of the microbes that really require carbohydrates. But it's very likely that they're eating those 500 grams of carbohydrates and also additional carbohydrates, and getting adequate fiber.
Yeah, there's probably practical things there that athletes with huge calorie needs, by being not elite, but a very, very good athlete, probably just conscious of eating anyway. So that's going to have a positive impact. Plus, if you've those really high calories, you're eating so much, very hard not to get the requirement for what you eat nutrient-wise as well.
Yeah, exactly. I mean, when people are eating 3,000 plus calories, you can kind of get enough fiber on accident.
it's almost a challenge not to get caffeine. Whereas that's why some of the more energy restrictive diets may see, particularly that one bothers you mentioned there, because you're more likely to be getting enough of 1, 2, 3, 10 nutrients at various stages.
Yeah. And that one, we don't have a lot on sort of like chronic dieting, but there has been one that I've seen recently that illustrated that people who were on a very, very low calorie diet did see some changes in microbial diversity and a relative increase in the abundance of some pathogens. So it could be that, if we are really limiting energy availability to the microbiome, that means that we're limiting its capacity to, play a role in immune defense. Now, when we're looking at like long-term extreme energy deprivation in individuals with anorexia nervosa, we don't have a clear characteristic change. So in some cases, we see increased diversity. In some cases, we see reduced diversity. So that kind of remains to be seen. And it could be that, diversity, again, is kind of like a Goldilocks thing. Too little might be problematic, and then too much might be problematic. It might be that you see, so many different observable species and a very even distribution, but that could be because you're seeing, a transitory effect of like maybe a gradual loss of beneficial microbes and then an increased relative abundance of potential pathogens. So we also have to keep that in mind when we're looking at this, that, we don't have a full picture of what's actually going on.
We've touched there on some things that may negatively impact gut health, and you mentioned it through that bodybuilder study. But fiber, it's one of you I've heard anyway that seems to, maybe not overly positively, but certainly having a decent amount of fiber in your diet tends to be almost a protective factor against gut health. Or I don't know, maybe that's not as safe to use, but it seems to be one of the strongly positively associated things.
Yeah, I mean, when we're looking at like population studies, we see that there are a number of health benefits associated with adequate fruit and vegetable intake and, whole grain intake as well. So that could be in part due to, direct effects on us and also effects on the microbiome that leads to positive downstream effects on us. So, certainly adequate fiber intake could be protective when we're looking at like cardiometabolic disease risk and colorectal cancer. And it's kind of, I find it interesting that like, it's hard for people to get on board with like eating fruits and vegetables just like for their own sake. But maybe the microbiome would be motivation enough to just like, start eating fruits and vegetables. It's actually really good for you.
It's just hilarious how many different things you talk about may impact health, but just being able to eat more fruit and veg seems to carry across so many different areas. One of the final thing that again is meant positive is fermented foods, and it will kind of lead into probiotics. So just tell us a little bit about that.
Yeah, so fermented foods and probiotics are actually two different things, but fermented foods might contain organisms, the microbes, that could also potentially be found in probiotics. So fermented foods they contain live microbes, and those microbes metabolize compounds in that food and can change the shelf life of the food, can change to a small extent, like the micronutrient availability of the food, and can change the taste of the food, and obviously can convert, non-alcoholic things to alcoholic things, and create things like yogurt and whatnot. So that, like, as I mentioned earlier, fermented dairy is considered to be a probiotic food because it meets the World Health Organization definition of live microorganisms that, when ingested, confer a benefit to the host. So probiotics are in isolation those microbes that can confer a benefit to the host, and that when ingested in adequate amounts. So the effects of probiotics are both strain specific. So you think of it in terms of like a strain of bacteria is very specific. It has specific behavior, like the difference between a dog and a dingo or a wolf and a dog. Very closely related, very different behavior. And they're also specific to the population and the disease state that we would be applying them for. So there's no kitchen sink, like multivitamin type of probiotic that everyone should take. And probiotics might not do anything in some individuals. Some individuals might be very sort of resilient and resistant to any sort of enrichment from oral probiotics. It's not to say that they're totally useless. It's just that, there are probably other things that one could do, like you mentioned, the lifestyle factors, before turning to a probiotic, or it's something that is done in addition to, pharmaceutical interventions, or in rare cases, probiotics might help on their own with something like antibiotic-associated diarrhea.
And that's something I want to touch on, that when it comes to promoting gut health, is it a case of we should do this or we should this, or is it more a case of let's avoid these other things that will negatively, because gut health in effect, if you don't mess up too much, we'll look after it, and we should stop doing these things that negatively impact it.
Yeah, that's an interesting way of looking at it. I would say, kind of borrowing from both. So there are some obvious things that we could limit that we do for health anyway, but, limiting saturated fat intake, limiting refined carbohydrate intake, limiting alcohol intake. Those are not in isolation. If we have some every once in a while, it's not doing direct damage, but it's just associated. Sort of, you consider it like a risk factor in a way, and if we have accumulated a bunch of risk factors and we don't have any protective factors, that's sort of an imbalance. But if we have a solid foundation of these protective factors, of physical activity, of adequate fruit, veg, whole grain, and bean and nut intake, and we're kind of getting we're eating fatty fish a few times a week, and red meat if we want to in prudent amounts, then if we want to have a beer, probably okay. If we need to go on antibiotics, that's going to be okay. It's not that we would expect our microbiome to never change. We don't want it to be static. We want it to be dynamic and adaptive, and that it'll take a hit sometimes, and then it'll bounce back to potentially a new healthy version of itself.
I think that's actually a really good point to try and let's wrap up on there. That here's the things great for it. We don't need to avoid completely, but here are the things built into your overall lifestyle that will not just impact positive health, but positive health in general. You run your own nutrition coach business. Feel free to plug that away, give an overview of how it works, because sometimes you hear nutrition coaching, that's just someone a diet plan or what's happened there. So feel free, give us a little explanation.
Yeah. So I have so I did, 4 years. I worked as an RP coach. That's probably where people are most familiar, became familiar with me. And that's kind of how I started to speak about gut health. And so with RP, I actually have just released the Science of Gut Health book. And so that's part of what I do, is I help people to navigate the very confusing world of gut health when they have a non-serious, non-clinical GI distress issue, So I can help them to navigate the process of a low FODMAP diet and provide education, and sort of disseminate the literature and communicate it for them in a way that makes sense. So on that side of things, there's a lot of education, myth busting, and helping people, just feel empowered and gain a better awareness and ability to, identify those red flags. But the greater majority of what I do now is the comprehensive coaching approach that I developed with my colleague Shannon Beer. And that is sort of an operationalized framework that brings together motivational interviewing, cognitive behavioral coaching, and acceptance and commitment training to help people really change their internal environment, so their thoughts and their beliefs and their feelings around food and their bodies, so that they have a greater capacity to navigate what is a really challenging food environment. So over time, they feel more balanced in their relationship with food and their bodies. And we take a non-dogmatic, a nutritionally agnostic approach. So we coach people who are pursuing intentional weight change and people who are taking a weight neutral approach. And what we are actually going to be presenting on very soon is the intentional eating spectrum. So it is a way to visualize the approaches to nutrition as either more internally or externally regulated, so relying more on internal or external cues, and things that can be either weight neutral or weight focused. And rather than picking one, we help clients borrow from each or choose an approach that is best suited for them. And so they can pursue their goals in the safest way possible. And as they're doing that, we can help them to sort of process their ambivalence. Sometimes they feel conflicted. I want to stop tracking macros, and I'm also afraid to stop tracking macros. So helping them to resolve that ambivalence. And then as they're facing challenges, whether they're external or internal, helping them to overcome those challenges or to continue on toward their goal, even when those challenges are present. And so that's what we've been working on for over a year now, and it's really been incredible to kind of see how it's helped people in terms of clients, and then also the coaches that I mentor. Their approach to coaching has changed quite a lot, and really, I would say that this kind of changes the way that you, and this is not hyperbole, it really does change the way that you communicate with and connect to other people.
It's amazing how after spending so much time in formal education on like what are termed the hard sciences, it still comes down to so much psychology and interactions with people and their perceptions and relationships, people, foods like that.
Yeah, absolutely. Yeah, that's why the slogan that I've coined recently is science fortified with compassion. So, we can have science and we can have a compassionate approach so that we are not using science on people. We're using science with people.
And that presentation, where can people keep an eye out for that one with channel on intention?
So they can go to btgcomprehensivecoaching.com, or they can find either one of us on Instagram. I'm Vitamin PhD and she is Shannon Beer _. And we are happy to chat, shoot us DMs, ask if you have questions. And we are, putting out regular updates about our content.
Absolutely brilliant. Thanks a million for your time today. Gabrielle, really, really interesting. And I really appreciate that.
Absolutely. Been a pleasure.